Hey guys, welcome back. So glad you're holding up fine. Yet another interesting talk, and this time by Michael Friedrich, who is a senior developer evangelist at GitLab. And in his talk, From Monitoring to Observability, eBPF Chaos, which focuses on the challenges developers face when transition to observability use cases with eBPF. Let's give the stage to Michael and let him enlighten all of us. Any minute now. Just give it a second. Till the time we're waiting for this to load. If you guys have questions on this session, feel free to post them on the chat and I'll transfer them onto Slack and let Michael answer it for you. Yeah. Seems like we might have a technical glitch. I'll try to do something. I'll play it on my system and just share that. Let me see. Give me a minute. Right.
Good day, good afternoon, good evening, wherever you are. I want to dive today with you into monitoring observability, how
Okay, sorry for that. I think there might be audio issues. I'll try to bring this link in. Okay, give me a minute. I think,
Good day.
yeah, I might be able to hear it this time. Cool. Let me know if this is working.
Good day, good afternoon, good evening, wherever you are. I want to dive today with you into monitoring observability, how I learned eBPF, how it helps debugging production, and how it relates to chaos engineering. My name is Michael. I go as DNS me here on the internet. I'm a senior developer evangelist at GitLab. And today we will learn a lot. So if you want to download the slides and learn async, that's totally fine. And in essence, it's a learning story. So before we start with eBPF, let's look how is observability defined. So like beyond traditional metrics monitoring, we're collecting different types, answering known questions, unknown questions, and figuring out what is going on in our infrastructure. We have seen a lot of data types, metrics, traces, logs, profiling, error tracking, and so on. We know that metrics with Prometheus help us solve all the problems, for example, with different data sources involved in observability. This is user level observability, I would say, but there are more data sources on the kernel level, like syscalls, network events, resource access, and so on. Now, this brings us to eBPF, because what is it and what problem does it solve? In its definition, it allows observability, security, and networking at the kernel level. It needed certain innovation in a stable kernel, and there are sandboxed eBPF programs as operating system runtime edition. Now, the use cases are, for example, high-performance networking and load balancing, tracing applications, performance troubleshooting, security observability, and so on. Getting started with eBPF is a little like, it takes a while. So my recommendation is defining a learning strategy, doing some research on all the resources, looking into, for example, starting with a virtual machine, and looking into Brandon Gregg's tutorial, for example. Practice, and also practice explaining things. Looking a little deeper, development is also like where to start. I found it pretty useful to define SRE and DevOps use cases for myself. For example, a program start and exit, observing C groups, TCP interfaces, and so on. Finding a compiler, and looking into the available libraries, which can be Go, Rust, or C and C++. From development into the actual use cases, like we want to debug and troubleshoot production, I found awesome tools already, but I wanted to like also provide an overview for the use case of observability. Like there is a Prometheus exporter with eBPF. There are open telemetry collectors using eBPF already. Pixie is a tool for Kubernetes observability specifically for developers. CoRoot on the other side also implements or provides Kubernetes observability and implements service maps in Kubernetes using eBPF. And another example for continuous profiling is Parker, where the profiling agent also uses eBPF for anything function call stack and whatnot. Now, from the security perspective, there are other tools like Cilium for network connectivity, security, and observability, including Tetragon, which was recently released last year. Tracy is also a tool in that area, providing runtime security and forensics, similar to probably Falco is the most mature in this area, providing a Kubernetes threat detection engine. And you can also use it for different other ways to see what a container is doing, and which was implemented in the GitLab package hunter, for example. And last but not least, thinking about what does SRE and DevOps need, like debugging a production incident and see what's going on. Inspector Gadget is a collection of eBPF-based gadget to debug and inspect Kubernetes apps and resources, which is pretty handy. I've also found Coretta recently, which implements Kubernetes service dependency maps using eBPF again. And last but not least, we also need to find a way to distribute eBPF programs, and Bumblebee allows to build and package these programs as OCI images, which is a great way to deploy. Now, within observability, we always get to see like alerts, dashboards, and reducing the mean time to response. So we get to see alerts, we need to correlate things, we need to integrate new data with collected resources from eBPF. We also have dashboards, which should provide an insight of what is going on, and also identify forecast and trends. So how do we verify that, verify reliability? Because everything okay or all okay doesn't prove anything. And all the tools are useless kind of when we don't know whether they are helpful or not. And this brings me to thinking of chaos engineering again, breaking things in a controlled way, verify the service level objectives, alerts, and dashboards, have chaos frameworks and experiments available. An example for that is Chaos Mesh, but there are many others. Similar like to looking into the Chaos Toolkit, which allows, for example, to integrate with Pixie, which is using eBPF already, and also think about integrations in CI/CD, or even like developing extensions. So how can we extend the Chaos framework? Chaos engineering then also comes to mind with security and observability, like going a little bit beyond and injecting unexpected behavior, doing sort of security testing, hardening software, and so on. Also an interesting area. But let's focus on eBPF observability chaos at first. So everything which is useful for observability should be broken in a controlled way. We do have the golden signals with latency, traffic errors, and saturation. We can use the existing chaos experiments. That's totally fine. When collecting metrics and using, for example, the eBPF events to Prometheus exporter project, we can think of, okay, this is an interesting project. We can use CPU stress testing, I/O, or memory stress testing, enforcing delays in there and see what is going on or how the application or the Prometheus exporter will behave. Another idea is looking into Pixie, for example, which provides service maps and auto instrumentation for the software development and applications. And we could consider actually firing stress tests or even like network attacks to see how everything is behaving and verifying that either the UI is okay, or getting to see how the application is behaving actually. For Kubernetes troubleshooting, I've mentioned earlier, like there's Inspector Gadget. We can trace DNS and much more with eBPF. It also provides a local CLI for virtual machines. And chaos injection could be DNS, my favorite, network out of memory, and so on. So this can be a helpful way to verify that actually the troubleshooting tools for us are okay. Going a little deeper into like Kubernetes observability on its own, CoRoot is a new project which uses eBPF for creating network service maps within the containers, and it also can detect out of memory kills and so on. Now, for the chaos experiments, I have imagined like breaking the TCP connections forcefully, increasing the network traffic, doing some memory stress testing, and actually getting to see what is going on. And hopefully the weather map is not green or the service map, but it's red, and we can verify reliability in our Kubernetes cluster. Breaking the thought into profiling, where the code is auto-instrumented with eBPF. And again, similar chaos experiment idea, CPU and memory stress testing to see that the call stacks are taking longer, verifying that actually what we're seeing, the data and the data collection itself is doing okay, and we are kind of simulating a problem in production. Last but not least, OpenTelemetry also supports metrics, and the maintainers also have started implementing eBPF in OpenTelemetry to being able to collect low-level metrics. There are different collectors available for the kernel, cloud, and Kubernetes. And again, typical example, create some chaos experiments for CPU, for memory stress testing, and also do some network attacks. This can be a helpful way to verify the infrastructure and the collectors, and also see that something is really collected in that regard. Now consider DNS, and there were certain projects for DNS monitoring with eBPF. I found a really long but really helpful article around this with a hands-on example. And when this is implemented, DNS chaos is still a thing to consider. Now, switching heads from observability to eBPF security chaos, I found it also interesting to think about the idea, what if chaos engineering or chaos experiment could inject behavioral data that simulates privilege escalation, sort of like a pen test from the red team kind of. Or another idea is like multi-tenancy with data separation and simulating access, which shouldn't be allowed. Now, then I came about looking at Tracy from Microsecurity, and Tracy has a functionality to hunt rootkits, so being able to detect syscall hooking. So when a rootkit is hooking in the syscall and overriding get dent, which is like directory listing, or even like the kill command, this can be a way to simulate to detect a rootkit. And the chaos experiment on the other side would be simulating the attacker and inject syscall hooking, for example, by installing a rootkit or something and using Tracy to actually detect that. On the other side, with Cilium Tetragon, it's even more like security policies and detecting something, for example, simulating a file access as a chaos experiment, or even like simulating a rootkit. So I found a diamorphine rootkit, I installed it in a virtual machine. For the first time in my life, it did crazy things. But I also saw that Tracy and also Tetragon were able to detect that and say, well, something is going on in your system and it might be compromised. So the chaos experiment rootkit simulation went fine until the point where I was like, okay, the rootkit shouldn't do anything harmful. So we might be simulating or just overriding the syscalls, but nothing else. Because when there is like harmful things going on in production, nothing works again, you probably end up with deleting the virtual machine or the deployment and starting again. And this isn't something we want from a chaos experiment. But the idea is still like, it's an interesting idea. Coming to eBPF chaos on its own, like the visions and adventures we can dive in, I would say like we can also think about better chaos engineering with eBPF, like using eBPF probes to inject something and change also the responses. I've thought about ways modifying DNS or even like accessing protected data. And Jason Yee on LinkedIn, my friend, also had kind of the same ideas when I was creating this talk. So there is a lot of things to research and learn. And I think it's pretty interesting. Using DNS chaos as an example again, with Chaos Mesh, there is like a plugin that implements the Kubernetes DNS-based service discovery spec, uses or needs core DNS. So I thought of, hey, maybe we could change that into an eBPF program that intercepts DNS requests. And I found an experimental DNS server, which is called Express DNS, which is written in eBPF. And the user space application actually allows to inject DNS records, which could be an interesting way to create a new way of chaos experiments in the future. Okay, many ideas, many thoughts. There is more things. To think about simulating a rootkit behavior, calling home, using curl or whatever in the background, intercepting traffic, causing delays, CPU stress, DNS chaos. This is something we can think about putting into eBPF probes. Now, switching sides, there's also chaos with eBPF. So we got a lot of work to do still. We need to ensure that nothing happens with eBPF programs and you install that and it works fine, obviously, or it should work fine, but it doesn't. So the eBPF program needs compilers and tests. We need to ensure that code quality is intact. There is no like supply chain attack in an eBPF program. We need to do security scanning. and also verify that the programs are not slowing down the kernel or something else. The problem with CI/CD is the verifier needs to run in kernel. So the eBPF program cannot really be tested in production in CI/CD. But there are attempts to create an eBPF verifier outside the kernel, which is a super interesting article to read, which I linked there, to really ensure that nothing breaks when we're writing eBPF program and everyone uses them, and then we have like either rootkit or performance nightmare on our own. Because there are certain risks as well, because it's a cat and mouse game with regards to preventing security exploits, but actually using eBPF to circumvent these measurements. And this is also an interesting area to follow up with and keep an eye out that eBPF will solve certain problems, but it probably won't solve all of them, and we should be aware of them. Now, last but not least, I do have a wish list with regards to eBPF on its own, like being able to have sleepable BPF programs, which means that you can kind of pause this on the kernel level. You don't need to exit, but can continue at a later point. Also thinking about like eBPF programs that observe other eBPF programs, not doing anything malicious, and also having a way of like a better understanding for developers, more getting started guides, more debugging things, and even like platform abstraction. So you can understand eBPF, but you don't need to. You can integrate it with Chaos Engineering, for example. But it's really like a useful package to consume in the end. Now, thinking about the many things I told you about how to debug production, how to use the specific tooling and the specific projects using eBPF and getting an advantage, this is also something like to consider for the future, because eBPF seems to be or is a new way to collect observability data, provides more network insights, and security observability and enforcement comes to mind. Chaos Engineering helps verify the collected observability data. It helps to verify the eBPF program behavior. And we can also use the technology on its own for integrating eBPF probes for Chaos experiments in the future. This brings me to like thinking about from monitoring or metrics monitoring to observability. We have moved beyond traditional monitoring. We're using like many different technologies to correlate, verify, and observe. We need to consider data ops. We need to consider ML ops, AI ops, anything which comes to mind, and take advantage of this, because there are certain benefits like observability-driven development with auto-instrumentation, benefits also from eBPF. We can verify reliability with Chaos Engineering the same way we did already before. And we also get to see better cloud-native security defaults. So anything which we kind of exploit with an eBPF rootkit or something in the future, this will get more eyes, and we probably or hopefully will see better security as well. Now, the to-dos, there are obviously always to-dos. eBPF program verification in CI/CD is something which is needed. Figuring out if the Chaos experiments based on eBPF probes can be applied in upstream projects like Chaos Mesh, Litmus Chaos, Chaos Toolkit, many different other Chaos frameworks and tools. And also more ready to use eBPF library abstractions, because if you're not deep down Go, Rust, C, C++ developer, it can still be challenging to really get started with anything. And also the toolchain and the toolkits and so on. Now, for learning tips, I did that myself, and I've also linked a demo project. You can learn eBPF in a virtual machine, use Ansible and Vagrant or something else. Take a step back when it comes to anything which is a kernel technology or name you don't understand. You don't need to understand everything related to eBPF, but a general understanding can help when the data collection breaks, when the Chaos experiments don't work, and generally everything which breaks. Yeah, that's about it. Thanks for listening. Thanks for all the for inspiring me to give this talk today. You can learn more about the GitLab observability direction over there. Also, the demo project is linked there. The slides are here as a resource, and you can also subscribe to my newsletter, opsindev.news, which provides more insights into all the things, learning eBPF, learning new technologies, diving into chaos engineering, and see how we can benefit from all this new technology. Last but not least, if there are any questions, please reach out to me as DNS me here on social media, on Twitter, on LinkedIn, on Mastodon, on gitlab.com, wherever you will find me. Thanks, and have a great rest of your day or new day or wherever you are in the world. Bye.
That was certainly great and a fresh take, like a really interesting take on observability, eBPF. Yeah, thanks, Michael, for joining, and thanks all of you for attending. I won't take much of your time. We are already having a break session, so yeah, take a breather. Go ahead, take a break. We just have one last session of the day for closing the third part of this Chaos Carnival. So yeah, looking forward to that, and hope all of you join that. And yeah, have a break, take some time out. Cool. See you again. Bye.